We're tackling the problem largest perimeter triangle, which we're going to try and solve with minimum complexities of O(n) log n time and O1 space. We can do better than the O(n) listed here, and this will be changed in our application. In any case, we're given an integer array nums, and we want to find the largest perimeter of a triangle with a non-zero area formed from 3 lengths in the array. If it's impossible to form any triangle of a non-zero area, we'll be returning 0. There are 4 methods to choose from, and you need to try and find the most optimal, which, as I remind you, gives O(n) log n time and O1 space. Your options are A. Sorting plus greedy, B. Dynamic programming, C. Hash table, or D. Binary search. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who recognize the most optimal solution, congratulations. And for those of you who just want to see the code, the answer here is A. Sorting plus greedy. We have a rudimentary brute force approach here, and that would be to generate all possible triplets of integers from our input array, and then check if they form a valid triangle, performing the calculation as we find one. This would have a time complexity of O(n) cubed, which is far from optimal, especially for those larger arrays. Let's take a look at our optimized solution. This simply sorts the input array in descending order using the sort function, as you can see up here. Note that it is in descending order, so you may not be used to seeing the .r begin. After that, we iterate through the array and check if consecutive triplets can form a valid triangle. So, we do so using this line. If so, we can return the maximum valid perimeter found. This approach has the time complexity of O(n) log n due to the sorting step, and space complexity of O1, because as you can see, we're not creating any additional data structures. We're employing a greedy strategy by starting with the largest side lengths to maximize our perimeter. And that's what we're returning. So, let's go through this line by line just to ensure full understanding. First of all, we initialize the variable sz with the size of the nums array. After that, the sort function is used to sort the nums array in descending order. This step ensures that the largest side lengths are at the beginning of the array. We then start a for loop with the index I set to 0 and iterating until I reaches size -2. This is because we need at least 3 elements to form the triangle. Inside the loop, we check if the condition nums I is less than nums I plus 1 plus nums I plus 2 is true. This condition ensures that the 3 lengths can form a valid triangle, that is, the sum of any 2 sides is greater than the third side. Back to primary school mathematics here. If the condition is satisfied, we return the sum of the 3 side lengths, nums I plus nums I plus 1 plus nums I plus 2, as our largest perimeter found. If no triangle is found after the loop, we return 0 as our default value. So this implementation efficiently solves the problem by sorting the array in descending order and then checking consecutive triplets to find the largest valid perimeter. The greedy strategy of starting with the largest side lengths maximizes the perimeter. So that's everything here, and that's another problem-solving session completed with Coding Card Sharp, where we've used sorting plus greedy to help solve this problem. This solution came from this course, and I can't recommend it enough. You can find Dr. Ibrahim's course in the description to this video. And to complete this video, Let's take a look one more time at the problem and the 4 possible methods. You should have elucidated that sorting plus greedy is the best one to choose for the largest perimeter triangle. Please ignore the memory complexity. It is O1, and that's going to be corrected very shortly. If you need a little extra help, we have the code available for you in C++, Python, and Java as well. Okay, that's everything for this problem. We'll be continuing the algorithms pack with array partition, and that's coming up next.